Hi, I'm Ben, welcome back to the channel, and in my last video I was testing out the Radtel RT-860, and a few of you said in the last video that you thought I might have been testing the wrong antenna port, so we'll take a look at that shortly. But I've also ordered the RT-900 and that's now arrived as well, so we'll take a look at the RT-900 in this video as well. So in the previous video, and if you haven't already seen it, I'll put a link in the description down below. I was using the Tiny SA spectrum analyzer to measure a few things on the Radtel RT-860, including the harmonics on transmit and also the receive sensitivity. So a few of you said you thought I was using the wrong antenna port, and I'll try and explain my theory behind why I was using what I was using. So this radio has got essentially two parts to it. The main transceiver part, transmit and receive, which has got a range of 18 megahertz right up to 520 megahertz, and I say it will transmit on VHF and UHF, and potentially it appears to try and transmit everything between 18 and 520 megahertz, although not particularly efficiently as we demonstrated. So my assumption was that all that would be done on the main antenna port. So if we switch the radio on, you can see I've currently got it programmed to UKCB channel 19, so 2778125. That's using that main transceiver. Main reason I was doing that is because the main transceiver will receive in AM or FM. There is a way using the software to do single sideband, which I think is probably double sideband, because you can't differentiate between lower and upper using that particular part of the radio. But if you want to use AM and single sideband, lower sideband, upper sideband CW, we need to access the shortwave side of the radio. So by pressing the side key there just once, you'll see it says radio starting, and although we're still showing the same frequency on there, you can see the screen has changed, and we're now using that SI 4732HF receiver chip. So basically this is a receiver only now. At this point it's not going to transmit, so I can't test any transmission on that part, and that was the part that I would assume would just be using the secondary antenna port. But so that was my logic behind the reason I was doing it the way I was doing it. But since a few of you said you're using the wrong port, I thought, okay, well, I'll test that theory out. So we'll put it back on the Tiny SA again and see what results we get this time on receive sensitivity on the main circuit. So I'm going to exit the shortwave side again, so you can see it's now put us back to the main circuit. You can tell it's on the main circuit because the screen has changed, and it'll actually allow us to push the PTT on this one. So I'll do the same test again that we did last time, and we'll see what results we get. So you can see I'm connected up to the Tiny SA again, so we'll do a transmission test, and I'm using that sort of main antenna port at the moment. I'm going to try not to get too much reflection. There we go. So we'll push the PTT. I'm not going to do the screenshot of this because it's exactly the same as last time. You can see there's awful harmonics on all over the band, so you can see that what the Tiny SA thinks I'm trying to transmit on is around about 111 megahertz in the air band there, which we're not. Obviously we're trying to transmit on 2778215, but obviously most of the power is going out somewhere else. So that was, like I say, for the main antenna port. So let's take that one off there now, and we'll just see if we're getting a similar result on the other antenna port, because I believe it's putting power out of both of them when we're doing this. So let's try again. So we're on the secondary antenna port now. Same test again, trying not to get too much light on the screen. There you go. So it's not actually, there's a little bit of power coming out of that one. It's probably not actually power coming out of that one. It's probably just because we're so close to it. So yeah, it just proves that the transmission on 27 megahertz is definitely coming out of the main antenna port. So we'll now do the receive sensitivity test and see how that compares. So for this test I've removed the 40 dB attenuator because we're only testing the receive sensitivity, and you can see that I've got -7 dB signal, which is going to be generated by the Tiny SA, and that's the most I can put into this. So I turn this on. There you go, you can just about hear that weak signal being received by the RT-860. So let's turn that off, and then we'll switch over to the other antenna port. And like I said, that was the strongest signal I could generate, or the highest power signal I could generate from the Tiny SA. So we're going to knock that signal right down now. That's, that was only just receiving it. So let's drop that right down to -67 decibels, and we've connected up to that secondary antenna port now. So let's now start that signal again. There you go, and you can see that we've got if it will focus, there you go, we've got S7 at -76, and if we increase that by 10 decibels, SA at 66. Again, apologies for getting so much light off the screen. And then by -46, you can see we've got a 20 dB signal on the radio. So yeah, it does receive CB if you plug into the right port. So receive on this one. There's no point trying to transmit, but any transmit power does come out of that one. But yeah, so yeah, apologies, Radtel. I was probably giving out some duff information. It does receive, but again, I wouldn't say this was any good for transmission at all. So as I also mentioned at the start of the video, as well as the RT-860, I've just recently ordered the RT-900 as well. So the 900 doesn't have the separate the 4732 circuit, which the 860 does, but does have a similar frequency range for the main radio itself. So this one also receives from 18 megahertz, so obviously includes the 27 megs CB. It's not going to do single sideband. It will do AM airband, I believe, but for UK CB, which is FM, obviously, we can program those in and it will receive. We haven't got a secondary antenna port or anything. This is just a what looks like the secondary antenna port on this one is actually as it should be. It's a rotary control knob, so you can select your different channels or VFOs, and a single antenna port as you'd expect. It's very similar to some of the Biofane models. You can see the light reflects nicely off the screen from my ring light, but quite a nice clear screen on this one. And it's this particular version's got Bluetooth as well, so I've Bluetooth programmed this. Although having said that, I was able to use the Bluetooth software, which is very similar to the Oddmaster. Looks like very similar. Oddmaster doesn't do it, but it's got its own kind of equivalent basically that you can program it with. Although it wouldn't let me put stuff like 27 megahertz in. These ones I've had to program in manually. So the instructions for the 900 come with a little QR code on the back. So if you scan the QR code, that will take you to the programming software for Bluetooth, which was handy. But yeah, it's a nice little radio. The box that came in was absolutely tiny. I don't know if you can see the box compared to the boxes that the box that the 860 came in. The little 900 was in a tiny little box. So yeah, I was quite pleased with that. It's a nice neat little radio. So perhaps we'll do a future video on the RT-900 as well. But just while we're talking about that, I want to reiterate how important it is not to attempt to try and transmit on the CB bands with these. Like I said, it will interfere with the airband, and some people think I'm talking rubbish, but if we do a quick calculation of the frequency, so at the moment, let's say we're using UK CB channel 19, which is 27.78125 megahertz, and we can work out what the harmonics are going to be, because the harmonics are always double the frequency. So if we do a little calculation there and then we times that by 2, we'd expect a harmonic on around about 55.56 megahertz, and then we'd get another harmonic on, by timesing that by 2, around about 111.125 megahertz. So remember that frequency, 111.125 megahertz. That is within the civil air band, and obviously that frequency is closer to what the outputs of these radios want to actually try and physically transmit on. Like I said, they're not designed to transmit on 27 megahertz. They're designed for VHF and UHF. So the VHF amplifier is going to probably put most of the power out on that frequency. Well, we know it does by what the results we got on the Tiny SA. So let's have a look at the SDR. And I say I wouldn't ever condone transmitting on these, but I'm going to do a really quick test just to see what it looks like on that frequency, to see if it would interfere with the airband. So you can see I've got the SDR software running on 111.125 megahertz in the airband, where we think we're probably going to see the harmonics. And the Radtel RT-900, I'm going to do a quick transmission on UKCB channel 19 on 2778125. There we go, test. There you go, and you can see it quite clearly coming up on the screen there. So if I switch that over to AM, so it's on AM, we put it on narrow FM, and I'll just turn the volume up a little bit, and I'll go in the other room and I'm going to do another quick transmission. So there you go, you can see it's definitely causing problems on the airband there, and I wouldn't condone doing that test. I just wanted to reiterate how important it is that we don't go transmitting on the CB bands using any radios that aren't designed to be transmitted on those bands. Anyway, let us know in the comments what you think. Apologies for my incorrect stuff on the previous video, but hopefully this rectifies it. And if you're not already subscribed, please hit the subscribe button. I know that it's only a very small percentage of my viewers are actually subscribers, but it would really help the channel out if you could hit that subscribe button. So until next time, I wish you best 7-3, and we'll catch you in the next one.